Let us start the tutorial with session on SAP HANA introduction. This session will give an insight into what is SAP HANA, why SAP HANA for business, and how it benefits the business as a whole when compared to using other traditional databases. Technically, main support to HANA technology is its in-memory computing power. You might wonder what is in-memory computing? Scientifically, HANA is a solution platform that has enabled organizations to run computer business transactionally and analytical operations up to 10k times faster than they did before. So it would be interesting to know a few fundamental approaches that HANA uses as well. But to provide all these, SAP HANA relies completely on its in-memory computing power. By definition, in-memory computing technology is a technology that allows processing of massive quantities of business data. It can consume huge amounts of business data in the main memory, that is in the in memory of the server, to provide immediate results from all kinds of analysis and transactions, thereby deriving the key values for the business execution. And how does this work is our question. See, SAP came up with innovative in-memory relational database management system, that is RDBMS, in comparison to already present traditional databases. This in-memory RDBMS makes full use of capabilities of current hardware innovations to increase appliance performance, that is basically application performance, to reduce cost of ownership, and to enable new scenarios and applications that were not possible before. See, basically in traditional databases, memory and CPU were very limited. These resources like memory and CPU were the bottleneck. They were not available in abundance. That means they were very costly. But in these days, we see that huge amount of memory is easily available. Say 1 terabyte of memory is easily available, is less in cost, and also processors have been available in multi-core technologies. Multi-core means huge amount of parallelization, large number of activities can be done parallelly. So with these hardware innovations where we can have huge abundance of RAM and multi-core like 64 cores, 128 cores of processors, we can have fast computing and also consume huge amount of data. So keeping this as a base, SAP HANA is able to offer much advanced technology, much advanced speed and result to key business. This possibility to perform fast calculations on in-memory data allows the creation and use of new applications that provide real-time business insight. So we can have real-time business integration, we can have real-time planning and fast ad hoc reporting based on transaction data. So real-time decisions are always possible using SAP HANA technology. So with the SAP HANA database, SAP has the opportunity to build a high performance system integrating business applications. That means we can use the existing SAP solutions like SAP NetWeaver, SAP BW, or any SAP Business Suite solutions to leverage the advantages, the benefits of SAP HANA database. So by integrating business applications and the database layer, which will give SAP an unique competitive advantage. So in this, how does it work? What is in memory again? See, all relevant business data is kept in main memory, that is RAM. So all read operations can run in main memory itself as well as write operations. So using this in memory, which is available in abundance to keep all relevant business data, we can avoid IO bottleneck. IO means input output bottleneck, which was the problem earlier with all the traditional databases. Main drawback with traditional databases was the IO bottleneck. But with SAP HANA, we have got rid of this IO bottleneck. But now the performance bottleneck stands between the in memory, that is RAM, and the CPU caching, which can be battled out by using the proper programming techniques. Well, we'll keep that apart. So in comparison to traditional databases, we have got rid of the input output bottleneck that we had, since we had to access the data directly from the disk at all times. So the more we can do directly on the data in memory, which is next to CPUs, the better the application will perform and the better the result will be for all kinds of business. So now let's take a look what are the advantages that SAP HANA can give us. See, generally, as I said, it can consume huge data size, that is large amount of data can be used. If normally with traditional databases, if we use large amount of data, slower the system gets, but SAP HANA doesn't get slow. And it can handle complex queries. All kinds of query complexities can be handled by SAP HANA. With traditional databases, more complex the query, longer it takes to return the answer. And next advantage, like quick absorption of change of data. With the recent business transactions, the data keeps changing. How quickly the system can absorb these changed data is what matters a lot for the result to be produced. So SAP HANA is very quick in this absorption of changed data. And ultimately, quick response time. So we have to measure how quick the database can respond to the changed data and thus giving the response. SAP HANA stands out when compared to all kinds of traditional databases. And speaking about more advantages, I spoke about general advantages now. Now let me come to specific points like how SAP HANA has been adding advantages, adding benefits to business. First point here is speed. By speed, I say that managing massive amount of data volumes, that is massive amount of business data at high speeds. As I said, it has huge memory, multi-core CPUs. So combining the power of these two, it can handle huge amounts of data as well as work on this huge amount of data parallelly by using high computing power of these multi-core CPUs. So the results have proven that it can run 3600x faster as compared to traditional databases on huge volumes of business data. Next is agility. By agility, I mean it enables real-time integration across value chain when business is happening. So it integrates with the entire business chain, end-to-end transaction, even when the business is happening. So it's real time all the time. In that way, it is agile. Next is any data. Any data means SAP HANA integrates any kind of data from any source, be it structured or unstructured, be it from internal or external sources. So it can integrate with structured and unstructured data from internal and from external sources both, and can work on detailed data without aggregations. So basically it doesn't need aggregations. It can work without aggregations. And with this, SAP HANA can be integrated into a wide range of enterprise environments, allowing it to handle data from any kind of traditional databases, also like Oracle database, Microsoft SQL Server, and IBM DB2. So it can consume data from any kind of sources. So in that way, we can say any data. Next is cloud. SAP HANA integrates to cloud business very smoothly. Since we all know that our business world is moving to cloud, SAP HANA powers our next generation enterprise cloud for fast, scalable, and secured environments. So it suits all kind of cloud platforms. Next is innovation. So by innovation, we mean SAP HANA is itself an early innovator for in-memory computing, as we all know. Its configurability, easy integration, and revolutionary capabilities make it flexible enough for virtually anything your business requires. So any kind of innovation that the business thinks of doing can be done by leveraging SAP HANA technology. Many companies are innovating new solutions using SAP HANA as a base. So we have varied number of solutions which are available in market using SAP HANA, and people are still driving these technologies, and there is a long way to go. There is still more success to come forward. And finally, the simplicity. You see that SAP HANA landscape or the SAP HANA architecture has only fewer layers. It looks very simple from landscape point of view and lower cost. SAP HANA implementation is something which can be achieved using lower cost methods. It's very simple for adoption. So with all these benefits, we can run business in real time and have results real time. So let me speak about some of the real time key values. Let me just take you through how, using all those technical advantages that we have, what are the business key values that the business can achieve. First is real time decision making. As I said, we can have real time integration to end to end business, to the entire value chain. So you can have fast and easy creation of ad hoc views on business, accelerate and access to real time analysis. We can have real time analysis and transactions. So real time results, real time decision making comes out with real time results. So day to day transactions or hour to hour, minutes to minutes transactions can be analyzed immediately, and we can take a decision for our business. Next is accelerate business performance. As I said, it has huge computing speed and consume huge amount of data, be it many terabytes of data also, petabytes also. It can consume that amount of data and forecast the business for planning, forecasting, pricing, offers, anything can be decided for the business performance. Next is unlock new insights. New insights means it can consume basically any kind of data, and it can take new innovations. So is flexible enough, is simple enough, So it can remove constraints involved in analyzing large data volumes, new trends, data mining, predictive analytics. So also take structured, unstructured data, as I said. It can take any data from any source, no aggregation required, so no time for aggregation wasted there. So immediate analysis, immediate results again there as well. And improve business productivity. As I said again from the previous key values, like we have immediate analysis, immediate results, and work on any kind of analytical models for analysis, analytics, and create new analytical models. So reduce reliance on IT, use data from anywhere. Again, using all this, we can have improved business productivity as a whole. And finally, improve IT efficiency. With these simpler landscapes, lower landscape costs, though it is working on used data volumes, we can avoid and improve. We can avoid any latency involved in the IT effectiveness and improve IT efficiency there as well. So, with all these advantages, I would again say SAP HANA offers what the business needs. Okay, now let us study about the business scenario, how business scenarios worked without SAP HANA. Basically, before SAP HANA was introduced into market, how business scenarios operated. So I would take it as a current state. A next state would be, that is the future state, would be using SAP HANA. See, in the current state, we all know that business has increased data volumes and it demands calculation speed and it has multiple data sources. And clubbing all this together, business needs quick responses. But with traditional databases, that is basically with traditional RDBMS systems, which were designed for optimizing performance on hardware, basically with limited main memory and limited CPU resources. So basically, it had slow disk input output as the main bottleneck, as I said before. And the focus earlier was to optimize disk access. For example, by minimizing number of disk pages to be read, number of disk blocks to be read into main memory when processing a query. So earlier, the experts would try to tune the traditional databases for achieving good response, worked on disk optimization. So there still existed this slow disk IO as the main bottleneck. And also, as I said, it had limited CPU sources. Traditional database systems where the CPU spent only half of the execution time for the real execution and half of its execution time in stalls. That is basically waiting for data to be loaded from main memory into the CPU cache. Again, latency there. And design included execution of data intensive operations at application layer itself. You all know that there's a presentation layer, application layer, and the database layer. So traditional databases operated on data at the application layer. So all this together resulted in increased amount of data that needs to be transferred between database and application layer. So again points to input output bottleneck. The read write from the disk always had problems. So hence traditional databases of online transaction processing systems do not use all available hardware efficiently. Though it had limited hardware, it did not use it efficiently. Hence, as a result, we see that there was a huge latency in obtaining real-time information for business decisions. The real-time decision making was not at all possible using the traditional databases. So in simple words, suboptimal execution speed, lack of business transparency, reactive business model, did not work out for the business. Business always seeked for something good, something better which can improve their business. So that gave a thought for SAP to introduce its new technology called SAP HANA. So let's now study about what happened when SAP HANA was introduced. So as I said, future state is all about using SAP HANA. As I said, SAP HANA was designed to exploit the availability of huge memory and multi-core CPUs, which is termed as the current trend hardware innovations. Thus, it made use of the current available hardware efficiently, which the traditional databases did not make use of it. And from technology point of view, in SAP HANA, data intensive calculations were moved to database layer. But in traditional databases, it was at the application layer itself. So moving this to database layer improved the performance. The burden of calculation was moved to database layer where the data is residing. So simple, easy operation on the data. Only the result had to be transferred to the application layer and the presentation layer. It made life simpler. So basically from this picture you can see that terabytes of data in memory or petabytes as well can be kept in memory, and 100 GB per second data throughput can be achieved, that is quick computing speed. With multi-core CPU architecture, I would say innovation as well, multi-core CPU innovations, we can have huge data throughput. See, this is huge. And any data source, any data, structured, unstructured, internal, external sources, anything can be consumed. So real time business information can be obtained, can be analyzed, results can be given to the analyst who are the decision makers for the business. So basically, flexible real time analytics, improved business response, and competitive advantage as a result of using SAP HANA. So as I said, data intensive calculations were moved to database layer. But how did it advantage? Pushing calculations to the database layer can also significantly reduce the amount of data that needs to be transferred between database and application server, right? So pushing calculations, we don't have to push the data to application layer every now and then. That latency is reduced. And SAP HANA database allows application developers to define application specific functions that are executed inside the database layer. By this application specific functions, I mean algorithms. So they can define it in the database layer, use it right there on the data, give the result. Well and good. And SAP HANA database is a full RDBMS, full relational database management system with SQL interface, transactional isolation, and recovery properties. That is basically ACID, ACID properties, and high availability. So with all these, see, basically to benefit from the parallelization and optimization capabilities of the SAP HANA database, applications must execute data intensive operations on the database level, which the SAP HANA uses or which the SAP HANA does with its technology. Hence, it makes optimum utilization of hardware and software innovations to provide real-time information for business decisions. So that's how we conclude using the hardware software innovations and pushing the data intensive calculations to database layer. SAP HANA is able to provide the needed throughput, the data throughput, and the needed business response. Okay, now let's study about what are the innovations the HANA technology has in it. So basically, they are classified into hardware technology innovations and software technology innovations. So under hardware technology innovations, you know that today's computer architectures have changed a lot. With multi-core processors, we have huge parallel processing possible with fast communication between processor cores. So huge amounts of data can be operated parallelly, and we can have very large main memory configurations and are now commercially available, easily affordable. Server setups with hundreds of cores and several terabytes of main memory are a reality now. So with all this, as I said in my previous explanations, we can have huge amount of business data being operated parallelly, thus obtaining the business response needed. Huge data throughput performance is possible. So there is a dramatic decline in price per performance, and there are various hardware vendors who are actually offering this right now in the market. And let's now move to software innovation, which plays a major role as well. So under software innovations, first innovation is clubbing row and column storage together. Conceptually, a database table is a two-dimensional table structure with cells organized in rows and columns, right? Computer memory, however, is organized as a linear sequence. For storing a table in linear memory, two options are possible, as you know. And with SAP HANA, these two options are row based store and column based store. In row based store, the data is stored as a sequence of records that contains the fields of one row in the table. So as a sequence of records. Okay. Whereas in column store, the entries of a column are stored in contiguous memory locations. You mean contiguous memory locations. There in row store it was sequence of records. Whereas in column store it is contiguous memory locations. So here column based storage adds advantage in reading and writing. And also storing in contiguous memory locations offers huge amount of compression. See, basically relational databases use row based storage, but SAP HANA uses a combination of row and column store. So it decides what kind of tables can be kept as row and what as column. So decision is made by SAP HANA by itself, or the developers of the table can take a decision depending on various guidelines whether to keep the table as a row based or a column based storage. As I said, SAP HANA database allows specifying for each table whether it is to be stored column wise or row wise. And even though we have stored a table as row based, it is possible to alter the existing table from row to column, also the vice versa, columnar to row based storage. And how do we make this decision whether to keep a table column based or row based? Coming to column based, see, column based tables have advantages if calculations are typically executed on single or few columns only, right? If the calculation is included for only few columns, yes, it makes sense to have column based tables. And second, the table is searched based on values of few columns. You know, there is a search technology involved, search option involved with SAP HANA. If the search is based on only few columns, then it makes sense to have the table as column based. And third is if the table has big number of columns, then it makes to store it as column based tables there as well. And fourth, if the table has big number of rows and columnar operations are required, like for example aggregation or scanning, etc., then it makes sense to have the table as column based again. And I compression rates can be achieved because the majority of the columns contain only a few distinct values in comparison to number of rows. So storing column based can result in obtaining high compression rates. And now coming to row based storage. See, row based tables have advantages if basically the application needs to process only on single record at a time. Basically many selects or updates of single records are needed, then it makes sense to have row based tables. And second is application typically needs to access the complete record, all of the table, then it makes sense to have row based storage. Third is the columns contain mainly distinct values, so compression rate would be low. So if the columns contain only the distinct values, again makes sense to have row based storage, and this can result in low compression rate. And fourth is if there are no aggregations nor fast searching like fast scan are required on the table, store it as row based. Doesn't make sense to have it as column based. And finally, if the table has small number of rows, for example could be like some of the configuration tables within the system which has very small number of rows, small number of entries, then it makes sense to have it as row based because they are rarely accessed. Okay. So with all this picture in mind, now let's come back to column based storage. What are the advantages it can offer? See, with use of column based storage, as I said, we can achieve high compression rates. How? See, if the column is sorted, there will be ranges of the same values in contiguous memory. So compression methods such as run length encoding, this is the compression method used, or another compression method like cluster encoding can be used more effectively for column sorting. Okay, so with this we can achieve high compression rates. Whereas in row based storage, successive memory locations contain data of different columns. So compression methods such as run length encoding cannot be used at all. Since in column based storage we have contiguous memory location in comparison to row based where we have sequential memory locations, the compression methods like run length encoding or cluster encoding can be used more effectively. So with all this, column based storage offers better compression factor, and this compressed data can be loaded faster into CPU cache. The size gets lower and the transfer gets faster. Very simple. So that's how we can analyze large data sets. And next is high performance optimization. With columnar data organization, operations on single columns such as searching or aggregations can be implemented as loops over an array stored in contiguous memory locations basically. Okay, see such as you can consider operational uh, or operation which has high spatial locality and efficiently which utilizes the CPU caches. Whereas with row oriented storage, the same operation would be much slower because data of the same column is distributed across memory and the CPU is slowed down by CPU cache misses. Okay, so thus using columnar storage we can have high performance optimization, that is better aggregations, better scanning is possible in compared to row based storage. And next advantage is elimination of materialized aggregates. So basically no aggregate tables are required. So in traditional business applications which use materialized aggregates for obtaining the improved read performance. That means that the application developers define additional tables when the application is being developed, in which the application redundantly stores the results of aggregates. For example, like sums computed on other tables for faster access. For the next faster access, the materialized aggregates are computed and stored either after each write operation on the aggregated data or at scheduled times. And the next read operations read these materialized aggregates instead of computing them each time. So they would act like a cache all the time. But with SAP HANA, which possesses high scanning speed of several megabytes per millisecond, in-memory column stores make it possible to calculate aggregates on large amounts of data on the fly with high performance. So there is no need of aggregation at all, no need of aggregate tables. So this is expected to eliminate the need for materialized aggregates in many cases. A huge advantage. Next is about parallelization. What is parallelization? How partitioning works? So by partitioning, we mean that we can dissect the data. That is, we can divide the data, keep it on different partitions for very good parallelism. For achieving parallel execution, we use partitioning. That's how, see, we use disk partitioning as a simple strategy for having faster disk access. So that's how it works out for parallelization also. And coming to column based storage, it simplifies parallel execution using multiple processor cores. In a column store data, this is vertically partitioned already. That means operations on different columns can easily be processed in parallel. So if multiple columns needs to be searched or aggregate, each of these operations can be assigned to different processor core. See, with this multiple cores available, we can divide the search or any kind of operation for different processor cores, thus achieve all operations with faster execution. So that's how the parallelization also works. So this was as a whole the software technology innovation. So clubbing this hardware technology and software technology innovation, we are able to achieve the desired performance optimization. Now, by learning all of this, so far we got to know what is in-memory computing and what are the advantages SAP HANA offers and how it offers from technical and business point of view again. So now let us summarize what is SAP HANA. See, the picture here shows the SAP HANA database. So above we can see that there are third-party tools, client tools, accessing the HANA database using different interfaces possible like SQL, MDX, BIGS. There are various other interfaces like HTTP and few more possible. And here we have HANA modeling flexibility, that is build your own models, analytical models based on the business, work on it. And on the left side, we can see SAP solutions, be it BW or business suite solutions, replicating its data to leverage the SAP HANA advantages. And here, as I said, BW again using the ETL method of replication, and any third party sources, any non SAP sources also can be clubbed to SAP HANA. That is, they also can replicate the business data to SAP HANA to leverage its performance. So basically, in simple words, SAP HANA is a pre-configured out-of-the-box appliance. It is offered to the market as an appliance. It is consumed as an appliance. So in-memory software bundled with hardware delivered from the hardware partners like big builds shown here can offer the real-time business values. So basically, as I said, uses the in-memory computing engine as the backbone for SAP HANA technology. and offers tools for data modeling, data and lifecycle management, security operations, and various other. Innovate your own applications on top of SAP HANA. So huge flexibility and simplification. And next is real-time data replication using various replication technologies, like one of it is Sybase replication server, or we can use SAP SLG or BobG data services technologies to replicate data from different sources and thus use or leverage SAP HANA. And support for multiple interfaces as shown here, varied number of interfaces. Multiple interfaces are available so that multiple clients can connect to SAP HANA, do reporting, consume data, do faster analysis, and can consume content packages like extractors, data models, any new packages, new delivery units developed can be consumed on SAP HANA, can be deployed, can be consumed. Huge capabilities enabled. Yeah, as explained, it can analyze information in real time at unprecedented speeds, large volumes of non-aggregated data, non-structured data. Create flexible analytical models based on the real-time business needs. Work on the historic business data. Foundation for new category of applications. Basically, the new generation of applications which will be introduced in future for business flexibilities can be consumed on SAP HANA. So it offers the flexibility for new category of applications. And it overall minimizes the data duplication, thus saving cost and saving time and offering good speed. So with study about why, what, how on SAP HANA, this is the picture of HANA overview. It looks very similar to what the previous picture displayed. Again, we can club any kind of business object tools, any other query tools, apps to talk to SAP HANA using various interfaces. As I said, it can offer multiple interfaces based on the application tools connecting to SAP HANA. Just that we have to load some libraries relevant to the kind of interface, and from there it works. And SAP HANA as an in-memory computing studio, a database with many engines like calculation planning engine. There are a few more engines like text engine, which will be explained in the coming sessions, and offers row column storage. So basically consuming the hardware and software innovations, it offers the real-time business needs. Yes, real-time data replication is possible. It also uses SAP Business Objects Data Services as a technology for application. So you can consume data from SAP Business Suite Solutions, Business Warehouse Solutions, and any other data sources, be it non-SAP as well. It can consume that data and work on it. So there is no need for aggregation again possible. So basically there are various technical components within SAP HANA which work on different ideologies, which will be explained later on. So with all this explanation, I still think that you would have some queries in your mind. Few of them would be, no, when SAP went to build HANA, they realized that the next generation of business applications would require a much more integrated approach than in the past. So as I said, SAP HANA is not built just as a database. It is built as a platform, as an appliance where we can build our own innovative applications. So we can build any kind of business needed real-time applications, the future generation applications on top of SAP HANA database using it as a platform. So SAP HANA contains out of the box the building blocks for entire enterprise applications. So it's an enterprise package. HANA can take care of the requirements that would be served by many layers in other application platforms. So it's simpler in landscape. In traditional platforms where there were many layers, but in HANA there are only few layers which can still take up this load. It can act as transactional databases, reporting databases, integration layers, search, predictive, and web. All these functionalities are possible with SAP HANA. So all of this served up working out of the box with a single installation called SAP HANA. And next is, where does SAP HANA come from? See, SAP built SAP HANA from the ground up. That is by consuming few of the available technologies like P star time database and the T-Rex search engine, BWA in-memory appliance, and the MaxDB relational databases. So by consuming the technologies which were available in these P star time, T-Rex search, BWA in memory, and MaxDB relational database technologies, SAP HANA was built. So it has been extended with intellectual property from the business objects and Sybase acquisitions with products like Sybase IQ and business objects data federator, which are supporting SAP HANA to offer the business needs. And next is what makes SAP HANA fundamentally different. See, SAP HANA is different by design itself. As explained, it stores all data in memory in columnar format and compressed as well. Because of which HANA is so fast, sums, indexes, materialized views, and aggregates are not required at all. And this can reduce the database footprint by 95% is what is proved. And everything is calculated on demand on the fly in main memory itself. This makes it possible for companies to run OLTP and analytics applications on the same instance at the same time. So basically, SAP HANA combines both OLTP and OLAP at the same time and thus allows for any type of real-time ad hoc queries and analysis possible. So as I explained, SAP HANA can offer both OLTP and OLAP together, which was not possible with traditional databases. So with all these advantages explained and knowing about why SAP HANA, how SAP HANA works, what is SAP HANA and its software view and what are the clients which can talk, how the data would be replicated. We are now good to go to next session, which would be about knowing architecture and implementation scenarios of SAP HANA.